In your home's wiring system, the power is normally carried by the hot wires to the load, while the neutral wires provide a return path to the source after the load. Both sets of wires enter your home through the utility's main service wires, running through your electrical service panel, and run side by side through every circuit in your home. Should some breakdown of the pathway occur, the power may instead flow through other materials, such as metal framing, metal pipes, or conducting but flammable materials in your home. This is what may happen in a short circuit situation, where most electrical fires and shocks originate. A short circuit is when electricity strays outside the wires that it is supposed to flow through. In other words, when it takes a shorter path. To prevent this danger, your home's electrical system includes a backup plan, a system of grounding wires that runs parallel to the hot and neutral wires. It provides an alternate pathway for electrical current to follow should there be a breakdown in the system of hot and neutral wires that normally carry the power. If a wire connection becomes loose, for example, or a rodent gnaws through a wire, the grounding system channels the stray current back to ground by this alternate pathway before it can cause a fire or shock. The grounding pathway is generally formed by a system of bare copper wires that connect to every device and every metal electrical box in your home. In standard sheathed NM cable, this bare copper wire is included along with the insulated conducting wires inside the cable. The bare copper grounding wires terminate in a grounding bar in your main service panel, and that grounding bar is in turn connected to a grounding rod driven deep into the earth outside your home. This grounding system provides a path of least resistance for electricity to follow back to ground should a break in the wiring system allow electricity to leak out of the preferred system of black and white circuit wires. In some instances the code requires electrical cables to have mechanical protection, in which case rigid conduit or flexible metal clad cable must be used. Metal clad, MC, cable is easier to work with than rigid conduit, and offers protection from fire, vibration, gnawing pests and physical harm in general. Metal clad cable comes in several varieties, but the type you'll find most commonly has 3 insulated wires, 2 circuit conductors and a green or bare equipment grounding conductor, protected by a flexible armor, usually made from aluminum. MC cable is identified by the gauge of the wire, not the diameter of the armor. The most common sizes are 14 gauge, 12 gauge, and 10 gauge. MC cable is used only with metal boxes. Plastic or fiberglass electrical boxes aren't designed to be used with MC cable. Even if you're able to rig up a connection to a plastic box, you will fail the electrical inspection. Make sure the metal box has knockout holes located where you need them, and don't rely on the spurs on the bracket to hold the box in place, add a couple of screws as well. Flexible metal conduit, FMC, is commonly called greenfield or just flex. The main difference between MC cable and FMC is that FMC doesn't have the insulated wires pre-installed. You have to pull them through after the fact. This requires more work, but gives you the option of pulling and protecting more than one circuit in the same conduit. It also allows you to add wires in the future, something you can't do with MC cable. FMC is identified by its diameter. The most common sizes are 1/2 inch, 3/4 inch, and 1 inch. Liquid-tight flexible conduit is installed wherever the wiring will be subjected to wet conditions. Liquid-tight flexible conduit is water-resistant, and is available without the wires installed, and in short lengths, or whips, that come pre-wired. There are 2 common types: liquid-tight flexible metal conduit and liquid-tight flexible non-metallic conduit. Liquid-tight flexible conduit applications include HVAC equipment, machine tools, marine equipment, motors and controls, printing equipment, pumps, refrigeration equipment, transformer connections, and outdoor lighting. Stay tuned to this site. The next nugget that I release will be a continuation of this video, where I will be diving into more detail of the essential rules. In the meantime, as a bonus and in the way of a thank you for your continued interest, I'm making available my 50-page electrical power crib sheets, if you haven't already taken advantage of downloading them. These were prepared for use with my courses. There is one section associated with each course, and are extremely valuable while viewing the course, as well as a recall of the pertinent formulas and information after the fact. The contained information is also useful during any technical career as a quick reference from time to time. Simply fill out the information requested when you go to this website. You can also directly access my StanStore courses at this website. https://stan.store/uppercase G, uppercase B, uppercase B.